Example 38. At a certain section of a very smooth 2-meter wide rectangular channel, the depth is 0.9 meter when the flow rate is 5 cubic meters per second. Compute the distance in 2 reaches to the section where the depth is 1.0 meter if the slope of the bed is 0.002 and roughness coefficient is 0.012. So there are 2 reaches. Again, the first part is to compute for the normal depth. And let's check if that normal depth crosses this range of depths so that we can validate our solution, as well as the normal critical depth. So this is the formula, delta x E1 minus E2 over S minus SO, assuming that the other depth of 1.0 this time is the downstream end. So depth 2 is 1.1 as downstream, that's our assumption. So section 1 upstream is the one with depth 0.9. So Q is area to the 5/3 S to the 1/2 over N perimeter to the 2/3. To compute for the normal depth where the flow is uniform. So S equals SO for that case. Area therefore is width times normal depth, while perimeter is width 2 meters plus 2 times normal depth, 2 times d sub n. So substitute 2 times normal depth raised to 5/3 0.002 raised to 1/2 over 0.013 times quantity 2 plus 2 normal depth quantity raised to 2/3. So using your calculator, the normal depth is equal to 1.114 meters. So this does not cross this range of depths from 0.9 to 1.1. It's outside. So okay. Then the normal critical depth, cube root of Q square, where Q is capital Q over width 2 meters over G 9.81. So it is equal to 0.8605 meters. This is the normal critical depth, 0.8605. So it does not cross also the range 0.9 to 1 meter. So let's continue with our solution by tabulation so that our solution will fit in this screen, So let's have the depth, the area, which is just 2 times depth, perimeter, width plus 2 times depth, hydraulic radius, area over wetted perimeter, velocity Q over area, then velocity head plus depth as energy, it may fall in energy 1, then the numerator, which is the delta of velocity head plus d, difference of the two sections. So we'll divide this into 2 reaches of 0.9, the next is 0.95, then the next is 1. So that we'll have 2 reaches. Then the mean velocity in meters per second, the hydraulic mean hydraulic radius, R1 plus R2 over 2. Then the slope, which is quantity n mean velocity over hydraulic radius mean to the 2/3 quantity square. Then the denominator, which is S minus SO. Delta X is numerator. This numerator here is E1 minus E2 divided by denominator S minus SO, assuming that the depth to where the value is 1.0 is downstream. And that's delta X for the first reach, then delta X for the second reach also. So the depths to be considered are from 0.9, because there are 2 reaches, so the next is 0.95, then 1.0. So area is 2 times width times depth, so 2 times 0.9 is 1.8. 2 times, in this section, 2 times 0.95 is 1.9, and 2 times 1 is 2 square meters. Perimeter is 2 plus 2d, so 2 plus 2 times 0.9 is 3.8. 2 plus 2 times 0.95 is 3.9. And 2 plus 2 times 1 is 4.00. Hydraulic radius is area over wetted perimeter, so 1.8 over 3.8, we'll just express it in decimal, 0.4737. 1.9 over 3.9, that's 0.4872, 2 divided by 4.500. velocity is q over area. So at this section where the depth is 0.9, 5 divided by 1.8 is 2.778 meters per second. 5 cubic meter per second divided by 1.9 is 2.632. And 5 divided by 2 is 2.500 meters per second. Then 2.778 squared divided by 19.62, that's this column here, 0.3933. 2.632 squared over 19.62 is 0.3531. 2.5 squared divided by 19.62 is 0.3186. Then this velocity head plus depth 0.9, so 0.9 plus 0.3933 is 1.2933. 0.95 plus 0.3531 is 1.3031. 1 meter plus the 0.3186 is 1.3186. So the numerator is simply, this is section 2, that is section 1. For this pair of depths also, this is section 2, that's section 1. So therefore, 1.3031 minus 1.2933, because this is section 2 minus section 1. Or, sorry, section 1 minus section 2. So 0.0098, that's 1.3031 minus 1.2933. So this is supposedly that value minus this value. So this is negative, negative 0.0098. Then the difference here, 1.3186 minus 1.3031 is 0.0155. So mean velocity is 2.778 plus 2.632 divided by 2. It's 2.705. Then the mean velocity for these pairs of velocities 2.632 over 2.632 plus 2.5 divided by 2, that's 2.566. The mean hydraulic radius is 0.4737 plus 0.4872 divided by 2, put it here, 0.48045, and 0.4872 plus 0.5 divided by 2, put it here, 0.4936. So we can now solve for the slope. Quantity 0.012, mean velocity 2.705 divided by mean hydraulic radius 0.48045 to the 2/3 quantity square. So it is 0.002800. Then here, 0.012 times 2.566 divided by 0.4936 to the 2/3 quantity square. That's 0.002431. The denominator is S minus SO. S minus SO is 0.0028 minus 0.002 is 0.0008. Then 0.002431 minus 0.002 is 0.000431. Delta X therefore is numerator over denominator. 0.0098 divided by 0.008, that's 12.25 meters. Then 0.0155 divided by 0.000431, that's 35.96. So the distance between 0.9 meter depth and 1.0 meter depth is, substitute, 12.25 plus 35.96 is 48.21 meters.